Dear friends, this is Indra Vichapti here in the episode of Mathematics and Statistics Learning. In the last episode, we started discussing bivariate distribution, especially the correlation between the variables. Today, in this 21st episode, I would like to continue this bivariate analysis with regression, focused on the modeling of data. But before diving into the topics, I would like to remind my 16th video that discusses the linear function. We discussed this type of linear function. Here we see that y is a function of x, and here is the data depth. The values of x are chosen independently, and y is computed using this function. This is the graphical display of the function. The pairs xy is plotted here, shown as blue dots, lies in a straight line that joins all the points. Hence, this is a linear function which represents a straight line. Today, when we discuss the topics, we shall start with similar ideas but with different data sets. In the previous video, we discussed using hypothetical data, but today we shall consider the housing data set, which is a real-time data set collected in a certain locality. This is a housing data set consisting of 545 records and 13 variables such as price, area, bedrooms, and so on. In the last episode, we discussed the visual display, that is, the scatter plot of price versus area. In the present discussion, we shall try to model the variable price as a function of area and display it on the scatter plot. Let me highlight something about regression and data modeling. Regression analysis is a statistical method used to understand the relationship between a dependent variable and one or more independent variable. It aims to model the dependence of the dependent variable on the independent variable, making it a powerful tool for prediction, forecasting, and understanding the underlying pattern in the dataset. Click the link listed below for the site that explains the process in detail. Linear regression is one of the most common techniques used in regression analysis. It assumes a linear relationship between the dependent variable and the independent variable. The relationship is represented by the linear equation. This is the mathematical form of the general linear model, where on the left-hand side, this y is a dependent variable and x's here are the independent variables. Betas are the coefficients, also called parameters, to be estimated in the model, and epsilon is the error term. In short, this linear model can be written as y equals xb plus epsilon, where y is a dependent variable, x is a row vector of independent variables, beta is a constant vector of coefficients, and epsilon is the error terms. The coefficients betas are estimated from the data using various estimation techniques, such as ordinary least square methods. We'll be discussing here in detail in a minute. This minimizes the sums of the squared difference between the observed and predicted values. Let's explain this least square method in detail that estimates the parameters intercept A and slope B in the model. For the ith pairs of the data, the model takes this form. Yi, the ith dependent variable, equals the intercept plus slope times the ith independent variable plus ith error. The goal is to find the values of A and B that minimize the sum of the squared differences between the observed values of Y and the values predicted by the model. Let's assume that we have these n data pairs. Following steps are followed while estimating the parameters using least square method. The first step is the minimizing the residual sum of squares, where the error or the residual EI is the difference between the observed value YI and this model value. And the square of this error is EI square. We aim to minimize the sum of the squared residuals known as the RSS. This RSS is the sum of the squared residuals. Our aim is to minimize this RSS. We use the partial derivative techniques of calculus to minimize this RSS. To find the values of A and B that minimizes the RSS, we take a partial derivatives of RSS with respect to A and B and set them to 0. First, the partial derivatives of RSS with respect to A is this expression, and we are setting this to 0. Second, the partial derivatives of RSS with respect to B is this expression, and we are setting this to 0. With little math, these expressions change to these equations. So these are called normal equation. We try to solve this set of normal equation to find the values of the parameters A and B. Since we know these values n, number of data points, some of the x values, some of the y values, some of the square of the x values, and some of the product values from the data. When we substitute these values in this normal equation, this turns to be a simple linear equation in A and B that we can solve easily to get these values. The value of the slope B is this, and the value of the intercept is this. Hat on the top of this letter B and A represents the estimated value. Once we get these values A and B, and this model is specified, Y equals A hat plus B hat times X, where A hat and B hat are the parameters, intercept and slope respectively, estimated from the data. In conclusion, regression analysis is a versatile tool that finds applications across various fields, enabling researchers and practitioners to uncover relationships in data, make predictions, and inform decision-making processes. By understanding the principles of regression analysis and its applications, individuals can extract valuable insights from data to solve real-world problems. So far, we are discussing theoretical concepts. Now, let's try to visualize how does this model works in our day-to-day activities. Let's visit the page where we can observe the scatter plot of the real-time housing data superimposed with model used for predictions. This is the page which displays the plot and the model. This is the model, and this red line is the graphical display of the model. Actually, we have 545 records in 13 variable in the data set, for which we are trying to model the variable price as a function of area. Here we shall consider a simple regression analysis considering only two variables, one independent variable area and the other dependent variable price. The model here looks like a linear equation in slope intercept form, like y equals a plus bx, where a is the intercept and b is the slope. In a similar fashion, here we write our model as price equals intercept plus slope times area, where this is the intercept and this is the slope. And these slope and intercept are called the parameters estimated from the data using the method of least square that we discussed earlier. In order to make the process interactive, each time we draw a sample of 150 records out of 545 and display the scatter plot and computes the corresponding correlation as well as finds the new model of the corresponding sample data. Each time we click the next plot button, it displays the new sample with the changed value of the correlation and the model. If you want to practice on your own, browse the web page of mine, www.teachyoumaths.com. This is the page. On Statistics tab, click Regression app on the right of Preliminary Statistics. You will reach this page. Click the Next Plot button. It displays the scatter plot here, along with the model in blue line. It also prints the model at the top of the plot, along with the correlation. Keep clicking the Next Plot button, and you see the plot changes with new sample and also the change of the print of the model and the correlation here at the top. Isn't it interesting and fun to play with? Good luck and happy learning.